In the last session, we looked at some of the copy options like these, right? Size limit, return on failed, truncate column, and force. So basically these elements will help us load the data with a lot more flexibility for us to be able to look at the data before loading, etc., and handle some of the issues. So today, but if you have noticed, for all the previous loading exercises, we have only loaded the data that is of CSV format. So, but most of the data that is computer generated will be unstructured data, and that is one of the best parts of Snowflake, that it can handle JSON data, even though it's a SQL based system. So typically there are definitely other systems that can do this, but conventional systems like MySQL, these sort of or SQL Server, they cannot handle unstructured data like JSON. So you have to actually need another tool or some ETL process that actually treats JSON data to structured data and then load it into these conventional databases. But here it's not the case. So today we'll basically see how we can treat and parse JSON data in Snowflake. So before that, I'm pretty sure every one of us have encountered JSON data in the past, and I have seen it. But I'll just for the everyone's sake, I'll quickly give a quick intro. So this is a sample of how a JSON data, one record or one row of JSON data will look like. So here we have. It will be normally rotated in this float brackets, and each attribute that we see here is a column, and the followed value is the value for that particular column, right? So this is a simple how it will look like, but oftentimes this data can get very complicated with certain elements in it. So this is the same example, same row, but with certain additional elements within it. So we have these simple columns here on the top, and there is a column called job, and here this particular element is known as nested element in JSON structure. So here within this parent element we have sub child elements. So here we are saying what is the title under the job and what is the salary for that particular person, right? So this is called a nested element. So there are child elements within that, and there is something also called as array element. So here we can see there is something called as a list of elements that will be given, and this is called array element. So these are all the list of companies that this particular person has worked with. So this is an array element, and there can be, to make things even more complicated, there can be a combination of these nested and array elements called nested array elements. And here we can see that in the example of spoken languages. So here we can see this overall is a list, right? It's an array, and within that array the first element is a particular language. So what's the language name and what's the level that a particular person is familiar with that language. And likewise we have three elements giving us data with related to three languages that this person can speak. So these are some of the elements that which normally complicate the JSON data structure, and we'll see how, when we have a data like this, how we can parse it in JSON in Snowflake actually. So I'll have gathered a sample data for that, and let me quickly show you the data. Okay, yeah. So okay, so if you can see this particular file here, I've just opened this JSON file in a text editor, and this data file is called HR data, and we have each line here is a row, and it has several attributes, some of which we have seen in the previous example, and we will try to parse this particular file into Snowflake and see how we can get this data into neat and tidy format so that it can be further used for any analysis that is required. So we'll go back to our Snowflake. Yeah, so that will be the main goal for today. And first, I'll give you a brief about, before we get started with the process itself, we'll see how, what is the overall process comprise, what are the general steps that comprise in parsing JSON data in Snowflake. So we'll take a quick look at that, and then we'll follow those steps to parse the JSON data. So simply, there are, you can broadly you can put them into 4 steps. so far we have created external stage object, right? And we have seen in the past that we can modify this stage object. It's basically a data connector, and so we have to create a data connector where my JSON file is present. So I'll have to create that first, and then after that I'll have to make sure that my file format object, let me come to the file format object. So obviously my second goal would be to get the data from that particular JSON source into into my Snowflake. That will be my first goal. So before parsing it or analyzing it, I should get the data from the stage into my Snowflake. So because for that reason, we will create a table. So this table is slightly different from any regular tables because the column that which we create in this table is of the data type variant, and it has the data type variant is something very interesting in Snowflake. What it means is basically it can handle the unstructured data. So be it JSON file, be it XML file, be it Parquet data, anything. So if when you are dealing with unstructured data, you first load it as a variant data type, and that way you will have the data in your Snowflake and then further parse it to do any analysis. So we will first create this table with the variant data type and then load this JSON data into this table with the variant data type, and then we'll continue with the parsing. We'll see how we can do each of these steps in detail. So our first step is to create this external stage, right? So I have created there's a Amazon S3 bucket where the HR data file that we just saw is present. I will just create an external stage for the same. So the location for that S3 bucket is this, and I'll create a JSON stage with the name JSON stage on that location, and I will just see the files which are there in that location once it's created. And I can see the HR data file that I've seen here, right? Okay, cool. Now that I've created the stage, if you would recall, there is another file format object that we have created, and this file format object typically holds information related to what format this particular file is in. So far we have only used CSV file, so a CSV file format objects. Now we have to create a file format object for type JSON. So I will create just like a file format object with a file. Just give me a second. Okay, just hold on, please. Okay, we'll continue here. So we will first create this file format object specifying the attribute type is equal to JSON. I'll just create that, and once that is done, I can quickly look at this file properties, and I can clearly see here this particular file format object has type JSON and the corresponding properties accordingly. Now I will go ahead, and in the second step that we have discussed, I need to create now the table with the variant data type. So I will have to go ahead and create that table. So what I'll do here is, so this is the table that which I'm creating in this DB, in this schema. Please create a table name called JSON raw, and there is only one column in it. I'm naming it raw file. So we are just trying to pull the entire file as it is into this column as each record, right? And I'm naming the data type for that column as variant. So I will create this table. Now the table has been successfully created. I will just make sure I will select this thing, and I have one column raw file and no data in it. Now all I have to do is use the copy statement and the stage that I've created on where my HR data file is present, and I will copy that as it is into my table. So now once this is done, just give it a second. Yeah, I can see that there are it's loaded, and of the 200 rows, all the 200 have been passed. Now I will select this data again, and so you can see each record there has been loaded as one row in this particular table. So if you would look at this data once again, here we will be able to see the structure of the JSON data and more clearly. So we can see those nested elements, the job related nested element, we can see that here. And there is for this particular record, this particular array is empty, but we can see that in some other records there'll be certain values. So there is an array element there, and there is a nested array element here. So we'll see how to get all these things, but before that, now first let's see. Obviously in this type, it's just though we have a table with JSON data, it's not ready to analyze, so we cannot use this format. So we'll first have to figure out how do we convert this into a proper structured table. And for that, it's a really simple technique only. So what you have to do is specify the column name and the attribute that which you want to look at with the indicator called colon, right? So once now it will try to get me the city value for each of the records. So if I just run from this table, select raw file colon city, it will give me all the cities for that particular field. Now likewise, there's an alternative way. Instead of, if you don't want to specify raw file, the column name, you can also use the column indicator. So this is the first column. What does this mean is this is the first column, but it's normally not a good practice. If you're sure that this number is correct, it will remain the same for the rest of the time. You can go ahead and use it, but if you're not sure if the table might change, new columns might come in that case this will not be the right number, because it will basically represent the column number, and if there are any new additions of columns, and that will lead to the wrong reference of the column. So yeah, so we will run this thing and it will give me the same first name of it. So if you can see, there are a couple of things that are happening. We are getting this quotation marks as well. Sometimes we don't need this, and obviously we can treat it further to remove it, but the simple way is to parse. Whenever you're getting these first name, last name, etc., whatever the fields, you just convert that into a particular data type. Okay, so currently they have not been converted, so that's why we are getting those values directly as it is, as they were present in the file. But we can just use double colons to convert the data type of a particular value as whatever the string or int or based on the data itself, and then you can see that it will be a little more tidy. So we can see here now first name has been processed clearly, and likewise I can do the ID value as well. I will convert this as integer, right? And yeah, so I can have all the ID values. So now using these colon and semicolon, I can convert most of the data files, right? All the columns. Let's take the simple columns. Let's get to the nested arrays, etc. later. So these are the simple elements in that JSON file, and I will just parse the ID as int, first name, last name as string, and gender as string, etc. And I will just convert this. Again, this is all referring, remember that we are referring to the raw file that which we have loaded, right, at the very first table with the variant data type. So all these select statements are up here, are queried on that particular table. So now we can see that particular JSON variant type data has been processed into a neat and tabular structure. So this is for simple statement, but now let's see how we can deal with the nested elements. So we have seen already. So this is one example of the nested element, right? The job column element itself. So within each value, itself is a JSON type structure. It's not a single value, but itself is it has a JSON structure. So for that, you just have to use the same terminology, but further add a connotation saying that, hey, within that parent element, give me this particular child element. So that's what we are doing. In this file, please go to job parent element, and within job, please use title element. Therefore, I will get those two values as separate values. Now, if I do this sort of a select statement, now these nested elements will also be processed into a good table. Now, obviously, I can do the additional statements to additional changes to remove these quotations, etc. I'll just convert these to proper data types, and now my nested elements have been also converted into a property. I can just combine this select statement along with the select statement that I've done previously to get all these things, both the sets of columns into a single table. Right, now let's see how we can parse the array elements. So array elements, this is an example of that. So here we don't have any values. This particular person has no previous companies he has worked with. This person has 2 companies, this person has 2 companies, and this guy has 1, etc., etc. Now we'll see here the arrays will be treated slightly different using the array technique. So this is not something new for us, but we'll just use these references to calculate call which element we want to look at. So here we are trying to pull out, hey, in this particular array element, please give me the first element of each. So that means it will check for all these elements and it will give me the, here in this case it will give me this particular name and it will exclude this one. It will give me first here, it will give me this one here. So let's quickly see this. So this is how you handle array elements, and likewise I can convert that into a string, etc. Now if I want, I can merge the previous results and here. So if we here, what I'm doing is these values are coming directly from the simple elements. This is coming from the nested element, job title, and parsed as string, and this particular value is coming from the array element as parsed as string. Right, I can put all these things together, and here I've just also shown array size of this particular previous company element. So it will give me how many elements are present for each and every person in that particular array, because we are only extracting one first element here, but we need to know how many are we missing. So in that case, I'm just putting a function here, array size, so that way it will give me how many companies that person has worked with in the past. So this particular table, we can see name, title, previous company, it's null, so it means he has not worked with in the past. Here we can see one company, but he has worked with 2, so there is one company name that we are missing. So there are certain, because of those reasons, in order to get that value, there are a couple of ways we can do that. We can do a union approach. So what it does is basically, first we will extract the first company name, right, with the 0, and then for the second company name we will do the same approach and union it with the second company name. So we'll quickly see how this works, and here we can see each element now has each person has now 2 records with the 2 companies. Since this first person has no companies worked in the past, so these 2 records are nulls for the previous company, but for the second person where there are 2 companies, we can see those 2 companies that are coming ahead. So there are we can so we have treated it, but we don't want these nulls, right? So if a particular person has not worked, we don't want multiple records, number 1, and secondly, at the moment it so worked for us that this guy is has only worked for 2 companies, but what if the person has worked for 5 or 10 or more companies, right? In that case, it will just be tedious for us to do union for all this thing all the time, and sometimes we don't even know how many times we don't have to union. So that will be a tedious task. So there is a better approach. I'll get to that, but for the time being, we'll just go with this, and towards the end I'll show you a better approach. So in order to exclude these null values wherever it is this duplication is not required, we can do a simple distinct star statement. So that way all those nulls wherever it is not required will be gone. So now we can see this particular person, it has only 1 entry, but whereas this particular guy where he needs 2 entries, that guy will have 2 entries. So, but it still has its own limitations as we discussed, but we'll get to those in a minute. So far we have known how to handle arrays, how to handle nested elements, right? Now let's see how we can handle when both these things are combined as nested array elements. I think we follow the same technique. It's just it's a simple one, but we'll just do a quick example. So this is a nested array example. So spoken languages, total is an array, and within array each element is an nested element. So we will use this particular one to parse this. So first we will get the array size. If you just want an aggregate data, hey, how many languages this person speaks, you can just do this particular array size function and get this particular result knowing this person speaks these many languages. But if you want the data, what languages those are, then you have to further treat the data. So what we do here is simple. We know how to handle arrays. So we will, within this spoken languages nested array, we will use 0 to get the first element, and that way, hold on. Yeah, right. It will give me the first language that is spoken by every person. First element of all the languages that they have spoken, right? So it'll only give me one language, and I can further treat this, since this is a JSON element, I can further treat this with using the dot notation that we have used in the past to split these into further columns, right? Now I'm trying to split these into language as of one column and the level as a different column. So I will run this thing, and so this language and level spoken is, again, remember, is coming from the first element, so that means only one language per person. And so this is how we can get the language per person from nested array elements. Again, we can use the same union approach if you want to get the first, second language, third language, etc. So I've created a simple union statement to get the columns for first language, second language, and as well as third language. So again, this has its own limitations as we discussed, but let's quickly see this. And yeah, so here we can see for each person, since we have unioned it 3 tables, will have 3 values, and each record will represent one particular language that person will speak. If the person speaks less than 3 languages, then accordingly there will be null entries in those 3 records for that particular person. Here we can see this person speaks all the 3 languages, and we can see corresponding languages and level at which he is. So this is one way we can treat the JSON data. And now let me show you the better way in order to parse these nested elements and array elements and exclude all these nulls, and also treat. Currently we have only dealt with 3 languages. What if there are 5 languages? Sometimes we don't know how many languages max a person can speak, number one, and it's not in our control. So we cannot always come back and change this code accordingly or write union statements for however many languages that the person can speak, right? So that is why Snowflake provides us with the function called flatten. Okay, so I will first show you the output, and then I'll explain how this particular flatten function will work. So what I'm doing here is I'm referring to the 2 tables here. First, the main raw table that I've created, and then I'm just passing the spoken languages element to the flatten function. Okay, and I'm converting that output of the flatten function as a table, and I'm using that table as a second table without any joins, actually just some 2 tables I'm referring, and I've put an alias for the second table as an F. So from the first table raw file, I'm taking the first name, it's a simple one that we know, and from the second table F, I'm putting we need to query on the output on the attribute called values. Okay, so this table and values of that table, please see the language. So let me actually, within spoken languages we have 2 elements, as we have seen in the past, right? There is a language element and there is a level element. So first let's show the output, and here we can see, so we will only get the number of elements as per the number of entries that each person can, or languages that each person can speak. So initially we used to get a null for this person, but now that was removed, and now we can see this person has 3, it will have 3 entries. If some person has 10 languages that he can speak, it will have 10 entries accordingly, without you having to manually or hard code the number of entries that you want for each person. So this is how you can flatten any data. So what it's basically doing here is it will as we've already discussed this, it will basically look for each element within the spoken languages nested array and accordingly treat that particular array based on number of entries it has. So that's exactly what is missing in the manual approaches that we have done so far, the union all. So it cannot dynamically apply how many entries it should apply for each record. So that's what it is missing, and it's causing either nulls or missing of data in some cases. This flatten function will dynamically take care of that, both those objects, and treat each record dynamically based on the number of entries that that particular JSON element has for each record. So this is basically how we can treat all the JSON data once using these simple select statements. Just to quickly recap, array elements, we use this referencing, and nested elements, we use colon to go into from parent level to child level. I'm sorry, not that. Yeah, here. So sorry, we use dot to go from parent level to child level, and we use double colon to convert that particular, assign a data type to that particular column. And we can use those three techniques to convert any JSON file most of the times. And once you have created such a JSON file, you just have to go ahead and create a table and copy all the data within that table. So that way it will be easy and stored and ready for any analysis that you want to make. So now this particular table has been stored accordingly. Any questions so far on either on what we have discussed? Okay, great.